Hi and welcome back. So this portion of our lecture for today is an example of a challenge. So we've been talking a lot about trig identities and trig expressions and using trig identities to simplify, or using fundamental trig identities to simplify trig expressions. And one of the places that I've said that this gets used is in the calculus sequence. And I want to show an example that actually shows up in Calculus 3 when I teach Calc 3. So Calc 3 is multivariable calculus. So that means that most of the time you have more than one variable that you're dealing with, and you're trying to talk about things like volume and surface area and properties of three-dimensional objects, which is pretty cool. So I highly recommend that if you have an opportunity, do take Calc 3. And in particular, one of the things that we talk about is surface area, and one of the examples that I use in my class is the example of the surface area of a donut. And so to calculate the surface area of a donut, we have to set up something called an integral. And we do this integral, and in fact it's called a double integral, and then we have this big expression in it that we eventually want to evaluate. But to evaluate it, we first need to simplify it. So here is what that expression looks like. Here it is. I'm just kind of going to have it all written down. We have the square root of negative cosine of t times cosine of alpha times 2 plus cosine of alpha, that whole thing squared, plus negative sine of t times cosine of alpha times 2 plus cosine of alpha, that whole thing squared, plus negative sine of alpha times 2 plus cosine of alpha, that whole thing squared. And then, to top it all off, we take the square root of that whole expression. Whoa. Okay, now this is what gets set up in the problem. And we want to take that entire expression and we want to simplify it to 2 plus cosine alpha. Believe it or not, this entire expression can be simplified to 2 plus cosine of alpha. Now, before we move forward, I do want to point out that in this problem there are two separate arguments. We have cosine of t and we have cosine of alpha. That's the multivariable part. And what that means is that we can't combine things that have two separate arguments into one expression. Cosine of alpha is very different than cosine of t. Okay, so let's do this. Now, the first thing that I would do here is, what I see is that I have these square brackets. Oops. I have these square brackets here that are saying all of that stuff in there is being squared. So each grouping is being squared, and the things inside of those groupings are being multiplied together, which means that I'm allowed to distribute the square on the outside to each term on the inside. So the first thing that happens is that I have negative cosine of t squared. When I square the negative, it cancels, so I have cosine squared of t. I then have cosine squared alpha, and this entire expression, 2 plus cosine of alpha, is also squared. Alright, so I've distributed that first square. We now move on to the second set of parentheses, and we would like to square everything in there. So first we have negative sine of t. We square the negative, becomes positive, and so we have sine squared t. We square cosine alpha, so we have cosine squared alpha, and we square the 2 plus cosine alpha, so that is now squared. And now we're ready for our last set of parentheses, and so we're going to square negative sine alpha times 2 plus cosine alpha. So we square the negative, becomes positive. We square sine of alpha, so we have sine squared alpha, and we square 2 plus cosine alpha squared. Okay, now all of that is still under a square root. Whew. Alright, you may want to pause, let your hand rest for a minute, because I wrote a lot of this ahead of time, so it looks like I'm writing really fast, but really I just pre-wrote it. All right, once you've taken a break and you come back, you might look at this and say, okay, what can I do next to try and clean this up? Remember, we want this whole thing to look like 2 plus cosine alpha. Now, as I am looking here, I have my first term is everything up to the plus sign. And then my second term is everything in the middle up to the next plus sign. And my third term is everything after the last plus sign. And what I notice that's going on here is that every single one of those terms has a common factor of 2 plus cosine alpha squared. So I'm going to factor that out. I'm going to pull that term to the front. So we've got our 2 plus cosine of alpha squared. And then I'm going to open up a big set of parentheses. And what I have left is the stuff. So let's see. So what's left over in our first grouping? We have cosine squared t times cosine squared alpha. And in our second grouping, after we've factored out 2 plus cosine alpha squared, we have sine squared t times cosine squared alpha. And then in our last grouping, after we factor out 2 plus cosine of alpha squared, we have sine squared alpha left. And still, the square root is over everything. Okay, so now I look at what I have in here, and I have this 2 plus cosine of alpha squared times stuff. Now, because this is under a square root, and that piece that I have underlined, the 2 plus cosine alpha squared, is multiplied times the rest of the stuff, I can pull that term outside of the square root, and what that does is the square and the square root cancel, and so now I have 2 plus cosine alpha outside of the parentheses, or outside of the square root, I should say, and then I just have the square root over cosine squared t times cosine squared alpha plus sine squared t times cosine squared alpha plus sine squared alpha. Okay, so far we have done really zero trigonometry. All the stuff we've done up until here has been algebra manipulations of trig functions, but algebra. So now here is where the trig comes in, and this is the cool part, or at least this is what I think is the cool part. Okay, so underneath the square root, that's where we want to focus right now. Looking at these pieces, one thing that I notice is that I have a bunch of cosine squareds, sine squareds, some have alphas, some have t's. But if I look carefully at the first term and the second term, what I see is that the first term and the second term have a common factor of cosine squared alpha. And so what I'm going to do is I'm going to factor out that cosine squared alpha. Alright, so we've got to write a few things down. Our 2 plus cosine alpha, our square root. I'm going to factor out cosine squared alpha from the first two terms. And that leaves me with cosine squared t plus sine squared t. And notice then I close the parentheses because I've only factored cosine squared alpha out of the first two terms. Okay, I still have a sine squared alpha at the end, and it looks like I'm missing a plus, so that should be a plus right here. There we go. Okay, now take a look at what is inside of those parentheses. Cosine squared t plus sine squared t. That makes me really happy because when we are talking about cosine squared t plus sine squared t, I immediately think about the Pythagorean identity, the best Pythagorean identity in the entire world, cosine squared t plus sine squared t is equal to 1. And that makes me really happy because I can replace cosine squared t plus sine squared t with 1. Alright, so before I write those pieces down, cosine squared t plus sine squared t is 1. Alright, and let's write this down. So we have so we have 2 plus cosine of alpha times the square root of cosine squared alpha times 1, which is just cosine squared alpha, plus sine squared alpha. And I already know where this is going. Cosine squared alpha plus sine squared alpha is 1. So we have 2 plus cosine of alpha times the square root of 1, which guess what? Square root of 1 is 1, so we are left with 2 plus cosine of alpha. Wow! That entire expression has just simplified down to 2 plus cosine of alpha. Alright, now when you take Calc 3, you're going to then use 2 plus cosine of alpha and you're going to do something called integration. And once you do that technique, then that will tell you all about the surface area of that donut up in the upper corner. Why do you care about the surface area of a donut? Because you want to know how much glaze you need to cover one of those donuts. All right, thanks for listening.